Hi, my name is Brendan, and I'm here to talk about one of the most powerful forces in our universe that is no bigger than this cube. And I'm talking about black holes. Black holes may be small, but they have a huge impact on the area around them. Black holes are formed when a sun collapses in on itself. But when the sun collapses in on itself, just like this cube, it doesn't actually lose any of its mass. It just gets a lot denser. And this creates a pull so strong that even light can't escape it. Nothing can escape a black hole isn't entirely black and white, because a black hole actually affects a huge area, and only a small bit of that, known as the event horizon, is the point where nothing can escape. This is easy to visualize with simple Earth gravity things. For example, if I jump, like so, I'll fall down at the speed you would expect from Earth's gravity. But the people up there in the International Space Station, they just float around all willy-nilly. But this does not mean they're not affected by Earth's gravity at all, because if they weren't, then the space station, instead of orbiting the Earth, would just go careering off in a direction until it crashed into something. This effect is only magnified with black holes because of how heavy they are. For example, let me use this piece of paper to explain this. So if you have a black hole, like my fist here, and something is flying around the black hole, because the black hole is so heavy and things closer to it are affected by its gravity more, the closest part of the object to the black hole actually ends up getting torn off and starts orbiting around closer than the rest of it. And this effect keeps happening until you have a super thin spaghetti-like strand. And this is why this effect is called spaghettification. These concepts are a lot easier to show if you have a new concept, which is the fabric of space and time. In reality, gravity doesn't work as a pull, but it works as an indent in the fabric of space and time. So if you take this parachute as the fabric of space and time, and this rock as anything with mass, when you put it into the fabric of space and time, it will warp it, causing it to create an indent which things will then be attracted to. A black hole works like this, except it's way, way denser. So, if I take these rocks and put them in the middle of my space-time to show a black hole, they make a huge indent in the fabric of space-time, which means if I have a ball, like this Earth, it will just get sucked straight into the black hole and get trapped within the black hole. But, when I go back to get my Earth, well, if I take my Earth again, and let's say my Earth is approaching with some sort of speed, the Earth will end up rotating around the black hole, like so. This is how black holes get their notorious spiral pattern from all the stuff that gets sucked in and rotates around it. But this allows us to show other concepts as well, like the escape velocity I mentioned earlier. It becomes a lot easier to show with the fabric of spacetime. For example, if this Earth was traveling fast, but not fast enough, it would roll up the wall, but eventually fall back into the black hole and get caught by its gravity. Light is the fastest thing in the known universe. So if light tried to escape and it wasn't too close to the black hole, it would just go wee and come straight out of the black hole's gravity with no problems. But if the light's too close, then it will try its hardest to escape, but it won't be able to. Because after the event horizon, nothing can escape. This is not just the fabric of space, though. This is the fabric of space and time. The point where nothing can escape is not only the point where nothing can escape in space, but in time. So in reality, nothing after the event horizon happens because time ceases to exist, because no time can move or escape. Black holes are one of the most powerful forces in the entire universe. They use up entire stars when they are created and can rip you into spaghetti strands with a gravity so powerful that when you get close enough, there is absolutely no way you can escape. They get their name from being holes in space-time that absorb all light. Because they absorb all light, that's where they get the black part of the name, and the hole in space-time is where they get the hole, shortened to black holes. Black holes are truly powerful, and I hope you never get near this pea-sized Goliath of creation.